Perfect. Hello, thanks for the introduction, Felix. My name is Dorian Grosch, as he said, and I had the opportunity to think hard for 1 year about something interesting to do with the catalog and maybe a better way to search in it. So my topic for today is an experimental project that I did with VuFind as the target system. And the idea was to think about natural language search. How can we realize this? What are the possibilities to work with this, and why does it even matter? I will try to use this. Okay, fantastic. We will start with this user interface component, the search bar, which is ubiquitous and everyone knows it as a part of a maybe a catalog system. But the fact is that, of course, like the expectations around search bars are changing all the time, especially also since 2022. We see this trend of users kind of starting to expect these kind of search boxes to accept natural language input, or to at least be able to handle it in some way. And another reason for trying to work with natural language inputs are that it actually reduces barriers for catalog use. Like Ralph also said, there's one possibility is to train people how to use the catalog. This is very costly, it makes complete sense, but generation after generation of new library users need to go through this training again and again, and to learn the special ways how to use the catalog, how it changed, or maybe even the special vocabularies that we use to do a very, very special advanced search. And that's just not scalable, in my opinion. So the vision would be to, of course, base the catalog development around the expectations, around the changing expectations of the users, definitely. So if people expect to be able to use natural language to state their research question, we should be able to accommodate that. And also to put the search optimization in the back end of the search. So not try to teach every new generation how to search, but try to be smarter at interpreting these research questions that come in very different kinds and forms, from very detailed to very fuzzy, let's say, and to catch all kind of these cases. So we start with an example of a research question that is very detailed. I know it's probably not a real world case, but it's just to give you an example of which kind of parts such a research question could have. And this is, of course, keep in mind, mapped to VuFind. So we're having this question. I'm looking for books and articles in English and German for the past 40 years about women's rights in Bolivia. So if we look at it, we see that there's definitely some sections that map one-to-one to filters and facets of VuFind. So we have the media type with books and articles. We have the media languages, English and German. Okay, fairly common, could also be more niche. We can go into that later. Then we have a publication period that is just circumscribed. So this is not the start year, the end year, but this is someone just saying last 40 years, or maybe the 90s. And we were, I would expect us to be able to handle these cases also. And last, we got the semantic, or maybe the topics of the search. And this is the most difficult part, of course, because someone might use other words to describe a search instance that maybe don't map one-on-one, or are not in controlled vocabularies that we can apply just from the VuFind catalog, but we need to dig a little bit deeper to find the most likely candidates for this kind of research. So my idea was to implement a kind of natural language interface to the StabiKat catalog without changing anything in the existing catalog system. Now, I realize I'm on a VuFind conference, and I might be a pretty beginner in the VuFind world. So my first idea was, okay, I have 3 months, I want to make it work. Let's find a way to build a new interface to the VuFind, to the StabiKat catalog, and then see how the idea is received, how we can work to make it better, how we can maybe integrate it. The second thought was that I wanted to use our hard-earned catalog metadata that is in the catalog, which is in itself a perfect, or maybe as good as it gets, a mapping from titles to topics. And we definitely want to make use of that, especially if people themselves don't make the connection, because it's just too overwhelming. There's so many classifications, there's so many topical terms. How should I know them? And in other words, what we want to realize is an automatic research consultation. So a process that transforms such a question in natural language to a very specialized advanced search in our catalog. Now, a graph about the technical architecture, so you can understand a little bit the flow of the system. So we start in the top left with this natural language search request that just gets written into a search box like I illustrated earlier, and we go through a query transformation. So this is the step that kind of splits up maybe this research question. So we see what are high-level concepts, for example, the media type, the language, the author, the publication period, stuff that can be extracted from the search question by natural language processing tools. For example, an LLM doesn't have to be, but is in this context. And the other aspect is the topic, so the semantic search. What are the topics the user is actually interested in? And this part goes into semantic, so vector search, which is performed on controlled vocabularies. So in our case, the Basisklassifikation and the topical terms of the GND. So these semantic terms are basically worked through this pipeline of embedding them and looking for most likely candidates in the controlled vocabulary. And then we get, for example, top N relevant classes or topical terms. To make this work, to make this kind of semantic search possible, we need to look at the vocabularies themselves and how we need to prepare this data to make it searchable in this way. As I said, I had like two proof of concept vocabularies that I worked with. The first one was the Basisklassifikation, so our in-house classification, which is fairly simple, I would say, as far as classifications get. So this is about 2,100 terms that are in a mostly two-level hierarchy. So it's pretty flat in that sense, but still, well, this is just an overview, don't get too much into it, but we have the problem that some classes share the same names because their meaning is just derived from their position in the hierarchy. So if we want to have one fancy column we want to do the semantic search on, we need to prepare the data. We need to put the name of the class in the context of the category. For example, if we talk about famous institutions of this field, then we need to say, okay, this is the famous institutions about chemistry or about biology. So we need to prepare the data further. Also, the Basisklassifikation has these kind of scope nodes, which are sparse, but they are there, that we also want to integrate. So then we have the most semantic information possible for one class, so that the semantic search over, for example, the topic Bolivia or women's rights works as intended. The second vocabulary that I used was the GND topical subjects, which is another size category. We have 200,000 at least, and these are just the topical terms. The whole body of the GND terms is much bigger. And these also have first one heading, so just one, usually it's just one word heading, which then has alternative terms and has also GND subject headings that are absolutely key to understand how the subject is put into context, because the same heading could have different meanings based on its category. So this is also data preparation task that needs to put the expertise of librarians to use to connect the semantic connotation of these headings to make one big column where we can do our semantic search over. And the summary is that we take the high-level facets, so media type, language, and so on one side, and then the top N relevant classes or keywords on the other side, and put them together into a classical, I would say, VuFind search request, which is just an URL with all the filters and facets applied. So in some way, you could call it a retrieval augmented search, maybe. if you want to call it like that. And this is then basically just the result of this transformation, and the user gets to the catalog, to the standard catalog, and can work further with the results. The technologies used for the different parts of this system are kind of designed to be modular, to be also drop-in replacements. So we have, for this kind of natural language processing, I used this fairly small LLM as far as they go nowadays. So the Qwen 2.5, 32 billion parameters LLM, which analyze the request, gets maybe the high-level concepts, and then gives the information to the next step. As an embedding model, I used the BGE M3, which is also able to handle multilingual requests. So the language of the user that the user is using is not that important anymore, even though there can be culturally sensitive topics that need further refining. The beauty of it, I would say, is that, of course, the machine learning field is advancing very fast. And we want to be able to use a system that has no pre-training steps involved. So we don't have to retrain it costly every time maybe we want to have a change. And also we can make use of the developments, for example, in the text embedding world by just using another, testing and deploying. So we can save a lot of time and development resources on that, I would say. And of course, the target system is VuFind, which doesn't have to be specifically the StabiKat catalog, but it just needs to work over this URL facet and filter mechanism. How does it look in practice? As this is a proof of concept in some way and an experimental development, you just have the search box, put in the question, the backend works, and you get basically a results page with some filters and facets pre-applied. This is a very basic setup, I acknowledge completely, but it's interesting to see that definitely we can work in this space, and we can see that a kind of automatically assisted research consultation is possible. And so we see, for example, here some topical terms who were selected and some facets over the metadata. An important part of this is that now we can ask, okay, what if the user writes a fantasy language or maybe a media type that doesn't even exist? So we need a special trick for that, which I want to share, because I worked with structured outputs. So a way to constrain the output of the LLM at runtime, at inference time. So we want to have a guaranteed valid JSON and guaranteed valid values. So we don't want it to output some fantasy language or other aspects that are then maybe they bring to an error in the search. So I, as an example, I brought here the list of valid media types that we currently support in the StabiKat, which can also change over time. But in this case, the LLM is, during this analyzing step, only allowed to choose from these values or also none. Of course, if the user didn't mention any media type, we don't want it to confabulate anything. So this is one way that I wanted to present on how we can steer LLMs to be also more controlled and do a little bit more of what we want. And another important aspect is basically that additionally to the analyzing of the request, we can also add qualitative aspects. This goes in the direction that Ralph presented earlier, where we have the search request and we try to deduce what the user is trying to do. And this can look, for example, this way that we say, okay, with this question, is someone looking for maybe broader topics, someone starting a research and maybe needs a class of a classification to work with, or someone maybe more interested in very specific combination of different terms. So maybe it would make sense to use the topical terms to guide his or her search operation. Also, we could say, okay, this looks like a known item search. Let's not do the optimization at all. Let's just put it into the catch-all field and save on energy and money in the process. So I think this is an additionally interesting field to try to anticipate or try to analyze this kind of search requests to steer the search process very in a fine-grained manner. And we can go further. For example, for public libraries, we can also say, this looks to be a search for a specific object, right? So in this case, pre-apply these filters, leave these away, so because we know, of course, our library, and this is as one of the examples how we can optimize the search in the background. So to wrap it up, what could be the next steps? Of course, we want to add new vocabularies. The Basisklassifikation and the GND topical terms are just a very, very small subset of what libraries use to catalog their stuff and to make it accessible. So we definitely need to incorporate more topical, more controlled vocabularies to make the scope broader, especially also for data that are get in from external sources. Also, we need to think about this kind of search intention logic. There we need expertise from every institution themselves that have maybe statistics on what their most used search combinations are, and we can deduce from that how to steer and how to fine-grain this kind of search optimization logic. Also, interface concepts, UX. As I said, I chose the most simple possible solution, but of course, other concepts are possible. Someone might maybe prefer a chat-based interface to steer their research. Maybe there's other concepts. I would be really interested to hear from you also, maybe even in the breakout session tomorrow. And in this session, we could also talk about how can we evaluate the results, the quality of this kind of research translation or this research optimization. And mainly, of course, how to integrate this into VuFind, into this ecosystem that definitely has some mechanisms to put this behind a rate limiter, for example, very important if we are definitely generating LLM calls within a search routine, and how to make it like just more polished in general. I will be really interested in your thoughts about the matter and also in your questions.